Hello, learners. So, I, Roneeta Purkayastha, Assistant Professor, Department of Computer Science and Engineering, SOET, Adamas University, welcome you to the session of data types and operators in Python. So, this is the roadmap. These are certain points which we will be discussing in our session today. We shall start our session with an overview of the data types available in Python. So we'll be going into the details of the primary data types used in Python. Then we shall demonstrate some examples how to use the various primary data types in Python with small examples. We shall discuss some examples on integers and floating point number data types, right? And then we shall see the concept of how to write an arithmetic expression using various arithmetic operators, and we will learn the concept of operators and operands. So what is the meaning of data type? Before going into the discussion of what are the data types available in Python, we will see what is the meaning of the word data type which we use in our program. So in last few lectures we have seen that to store a value, we just use the concept of variable into which we can say that it is a named location into which a variable value can be stored. Now, Python is a dynamically typed language where we do not need to explicitly mention the data types. We just use the declare and use the value directly, and this value can be of any type like numeric type, integral type, floating point type, complex data type, or some other data types of advanced in nature like tuple, list, dictionary, etc. Right? So we do not need to declare the data type. We do not need to mention the data type explicitly, but just we need to use the value that we want to use throughout our program. So this is the reason why Python is known as a dynamically typed language, unlike C++ and Java. Now, coming to the types of, or the rather the categories of data types we have in Python, we have the first data type, which is the integer data type. As we know, an integer is such a data type into which we can use only whole numbers. That means any number without any decimal places. Like for example, 5. 5 is an example of an integer. But if we write the same number as 5.0, then it becomes a floating point number. We shall see what is a floating point number in the next data type category. But for now, you just try to understand that any whole number without any decimal point, it is known as the integer. Now we can use the type function and pass into it the parameter of the integer that we want to check whether it belongs to the integer data type or not. We want to check what is the data type of the particular number. So we just use the type function in this case, right? So how can we create an integer? So we can create an integer by simply typing the number explicitly, or we can just use the integer function. We can just use the integer function to create the particular integer. So let us see one example into which we can write a Python script and use an integer. So I'm just opening the prompt. So you can issue in the command, this command to open the Python IDLE. This is the IDLE screen into which we have created the q.py script. So you can give any name to the file into which you want to write the program. So here you can write your particular Python program. So I just want to show you the usage of integer data type. So I have taken a as the variable name into which I have stored the value of 10. And here I want to display the value of a, the variable a. I want to access the value which is stored inside a, right? So I'm just saving it and I am executing it. So you can see into the IDLE shell, we are getting the output of 10. Similarly, if you want to suppose check the data type of the variable used a, right? So you can directly use the type function and pass it to the print function. Now if I execute it, you can see that it is showing an additional line along with the 10 in output, that it is an integer. It is of integer data type, right? So let us see the next data type, which is a floating point number. Now already I mentioned in the previous slide that floating point number is a number with a decimal place. Okay, so 5.0 or maybe minus 6.0, these are all coming under the floating point data type. Here also we can use the type function, all the type function, and pass the particular floating point value into the type function. Floats can be created by typing a number directly into your code or by using the float function. So let us see the particular example. Here I will change the value of the variable a to 10.8, and if I save it, then execute it, you'll see that it is printing the output 10.8, which is a floating point value, and you can verify it easily from the next line, which shows the class as float. So this is a floating point number, a number with a decimal place. So next, if we have like v equals, we can use the float function to convert a particular string to its float equivalent. So let us see what will be printed by this print B statement, and also the print type B. This time we are going to get 4 lines of output due to 4 print statements. So you see, we have got 10.8, which is float, and 1.23, which was originally a string. So it has been converted into its float equivalent by using the floating point function, and we got its equivalent class as the float. So I hope it is clear to you all how the type function has been used and how the float function has been used here. Moving on to our content next. So we have the concept of an expression. So expression means it is written with the help of operands and operators. Now what is an operator and what is an operand? Operators, generally the arithmetic operators, are the mathematical symbols that we use in our expression, like it can be the addition symbol, the subtraction symbol, the multiplication symbol, or the division symbol, or the modulo operator. So we can use these operators and use them to apply over the operands. Operands are the values onto which we apply the operators. So the first arithmetic operator that we are encountering is the addition operator. So here we can see that 1 plus 2 has been written into the shell environment, and we got its corresponding output as 3. So in this particular 1 plus 2 expression, the two numbers on the either side of the plus sign, they are the operands, and it is quite interesting to know that it doesn't matter if both the that means whether both the operands have to be of the same type or not. They may be of different types. Like in this particular example, you can see that 1.0 plus 2. That means we are adding a floating point number to an integer number. So this is also possible. But what will be the output in this case? The output is going to be the floating point value, because every time a float is added to a number, the result or the outcome is another float. And adding two integers will always give you an integer only, an int only. But if one of them happens to be a float or both are float, then the outcome will also be a float. Let us see the demonstration of addition. So I'm just clearing the screen, and into the Python script we will issue the addition command. Suppose we store a is equal to 2, b equals to 9, and we take third variable and issue the expression using the arithmetic operator plus and the operand a, b, and c. And also kindly note that equal to is also an operator which is an assignment operator. We execute it. So you can see we have got the output 11. So this is the ideally shell. Here also you can directly give small addition commands to check the output to see whether your expression is okay or not. Okay. So if any of these uh, operands happen to be a float number added to an int number, we will get it as float value only. So next is the subtraction. For subtracting a particular number from another number, we use the minus symbol, and here also just similar to the addition. It doesn't matter whether the two data types will be same or different. If they are same in nature, like both are integers, then you are going to get an integer. If one of them is float or both are float, then you are going to get a floating point number as the outcome. So let us check it out, the subtraction part. So same program, we can just change the arithmetic operator of plus to minus, right? Save it and execute it. So 2 minus 9 will give you the output of minus 7. This one. I'm just highlighting it onto the screen. This is the minus 7, the output which you are going to get, right? And if any of them involved is floating point number, so you will get a floating point number only as the outcome, right? So next type of arithmetic operator is the multiplication. So we use the asterisk symbol, that is the multiplication operator, to multiply two numbers. Just similar to the case of addition and subtraction, in multiplication also, if any of the number involved is float, then the outcome will be a float, right? So we can say that multiplication too follows the same rules as in the case of addition and subtraction. So let us see the demo of this particular example. So just change this operator to asterisk and you are good to go. Execute it. So you will get 18.0. Why 18.0? Because one of the operands involved was a float number 9.0. This is the reason why we are getting 18.0 as the output. So whereas if both would have been integer numbers in nature, then we would have got 18 as the output, which is an integral number. So I hope you have understood how the addition, subtraction, and multiplication follow the similar kind of rules. Next is the division. So kindly note that we are going through only the arithmetic operators in this particular session. So there are some different kind of operators too, like relational operators, compound assignment operators. There are different kind of operators we have already, which are already available in Python. So into this session, we are only studying the arithmetic, the basic arithmetic operators. Okay. So continuing our discussion, we have the division operator. So here it will be used to divide two numbers. So here we can see, although 9 and 3 are both integers, it is not generating integer as the outcome, because division has got little bit different rules compared to addition, subtraction, and multiplication. Here the outcome is always float. So 9 by 3, 3.0. 5.0 by 2, 2.5. And if you want to convert the outcome to its integral part, then just use the int function to achieve this. Now we have to notice that if you use int function for the converting the outcome of a division operation, then it will discard any fractional part, right? It will discard any fractional part. Let us see this program. So suppose I change this to 9, this to 2, and this is divided by. So 9 by 2 will get 4.5, right? 4.5 is the outcome. Although both are integers, we are getting floating point number as the outcome. Now, if we use the int function over here, so what will happen to 4.5? It will give 4. 0.5 has been discarded. So it will only return the int conversion function will only return only the integral part of the particular result, right? Next we have the integer division. So this is a specialized kind of division operator known as the integer division operator. So 9 by 9 divided by 3 separated by the integer division operator will give you 3, and 5.0 by 2, this will give 2.0. Next is the exponent. So uh, we generally use the exponentiation operator in different mathematical expressions like 2 cube, 3 cube, 4 cube, 4 raised to the power 3, 2 raised to the power 3. So this is the symbol, exponent symbol, used in Python to calculate 2 square or 2 cube, right? So let us see the demonstration of this particular example. Change it to 2, change it to 3, and here change the operator to exponent, and we want to print C only. So it should print 8. Yes, it is printing 8 over here. Similarly, if you want to calculate 4 square, yeah, you can just change the value. So 4 square is 16. So you can see from the screen that we have got the corresponding output. Next in the list of arithmetic operators is the modulus operator, right? So modulus operator is different from the division operation. How? Modulus operator means when the left operand is divided by the right operand, then what is the remainder left? So if 10 modulo 3 we perform 10 modulo 3, then the outcome will be 1. Similarly, 5 modulo 3, the outcome will be 2. 20 modulo 7, the outcome will be 6. So 20 modulo 7 means when 20 is divided by 7, then what is the remainder? What is the remainder left? Okay. So let us see the demonstration. So change the exponent to modulo. So this will give you 0. So can you tell how it is 0? Because 4 when divided by 2, the remainder is 0. That is why we are getting a 0 over here. Similarly, if you change this to suppose 3, then it will give 1 as the output. Okay. So these are some of the references we have used in the particular presentation. So I would like to conclude the session here over here. So how did we start the presentation the discussion? We started off with the concept of data types. We discussed the primary data types of integer and floating point number only. And then we discussed about the concept of operators and operands and an expression. What is an expression? We studied the arithmetic operators in details right from the beginning, ranging from addition, subtraction, multiplication, division, exponentiation, and modulus operator. So we have seen how the outcome depends on the data type of the operand and what are the rules followed in each of the case of the operations. Right. So there are some more data types and some more operators used in Python. Like we have the data types as list, tuple, then set, dictionary. So all these different types of data types are used depending on the set of values we have in our hand for solving a particular problem. Whether the set of values can be modified or not, whether they cannot be modified. We have different syntax and different notation for storing these values and using them in our program, right? So, in a nutshell, I told you about all the points discussed in the presentation. Hope you enjoyed the session. And in any case, if you have any doubt, then you can write to the mentioned email ID. Thank you for your participation. With this, I am concluding the session. Thank you.